this one's actually a fun one. It's a lot simpler than I thought it was when I did it the first time. But here we go. I'll read it out for you really quick, and then we'll get into it. Maximum unique subarray after deletion. So it says you are given an integer array nums. You are allowed to delete any number of elements from nums without making it empty. While performing the deletions, select a subarray of nums such that all elements in the subarray are unique, the sum of the elements in the subarray is maximized, and return the maximum sub of such a subarray. So we have example 1, 1, 2, 3, 4, 5. They're all unique, so we don't have to delete any of them. And we can just hit sum, and output is 15. 5, 10, 15. Okay. Example 2, 1, 2, 3, done. We have to delete all of these to make this unique. And then let's see, they have the explanation, delete the element, perfect. Now, okay, here's a tricky one. Let's see. The output is only 3. And it says delete the element num2 because that's -1, num3 that's -2, and now we get 2 and 1 from to obtain the maximum 3 because we had to delete the repeat of 1. Okay. So we have a relatively small constraints. Nice. Now, first, we were going to see what our best possible time is. And because we have to iterate over every single one of these, the absolute best time complexity that we can get for this problem is O of n. So we know that. That's assuming we can get it. We should be able to get O of n, no problem. As for space, we don't. It's bad practice to mutate the input. So we'd probably just want to make a copy of this, or make another list that we put in unique elements in. So assuming that we delete none, we would still be making a copy of this. So space will also be O of n. We shouldn't need extra space for this. All right, let's do it. So first, what we're going to want to do is get the length of nums so that we're not putting hits on the stack every time we check the length. So we will go n equals len nums. Now we will make our storage, which is another list, and we will call it return maximum sum. So we'll call this max sum equals, and we'll declare that. No, we won't. Now, what we will do is we will iterate through nums, and if it's not in max sum, we will append it. So we will go for num in nums. If num not in max sum dot append num. And then we will go to perfect. And then we will say, I saw earlier that we have to return something, return the maximum sum of such array. and then they do have negative numbers in here, so we have to take that into mind. Let's say for num, if num not in max sum, we want to make sure that we're only appending positive numbers, and num greater than 0. Max.sum append. Okay, and then we say we need to return. So this is kind of cheating because I did see this on the solution that we do need to account for if there's only negative numbers, because we can't return an empty array. We need to return something. So we need to say if len max sum is equal to 0, return. We need to return something, so we're going to return the maximum value in nums. Return max nums. And then we will just say return max sum. That's it. Return max sum. We actually didn't need this len. We didn't need to take that, so let's clean that up. Hit run. Wrong answer. What happened? What happened here? Let's see. The output was 1, 2, 3. It was just 1 and 5. 15. Also we forgot to hit sum. So we'll do sum max sum. So what happened here? Yep. We'll try that again. Boom. Submit that. And that's it. Okay. Cheers. Enjoy.